Hi everyone, welcome to Flex Talk. I am Tara Dunn with Omni PCB.
And I'm Elizabeth Foradori with Omni PWB.
During our sessions, Elizabeth and I specifically focus on things related to Flex and Rigid Flex design and manufacturing. Today we'll be chatting with Ashley Luxton of Graphic PLC about key items to keep in mind when you are designing a part that will be prototyped domestically and then transferred to higher volume production offshore. Ashley, thank you for joining us today.
Welcome.
Your company provides quick-turn prototypes, and you also provide an option for higher volume offshore production, so you're experienced in this type of project transfer. In your opinion, what things should be top of mind when selecting suppliers?
Well, I think if you're working on a project that you know is going to go offshore for production following domestic prototypes, then you need to find a supplier who's willing to give you the technical support right from the beginning, from the design stage. Obviously, they'll have good knowledge of not just their own plant's technical capability, but also the offshore partners' capability as well. So they need to give you all of that information and that support at an early stage. So it's about finding a supplier who is in a position to give that kind of support and who's happy to do it. If you go to a supplier who has a partnership with an offshore supplier, they may sometimes prefer to send work there. They may be asking you as a customer if they can send work out there, but all of that sort of thing, it needs to be agreed and it needs to be clear. Not everybody's happy to have boards made offshore in the Far East because of data security issues and things. So whether you are looking for your supplier to send work there in the long term or in the medium long term, it needs to be made clear to them so that they know that that's the goal. And equally, if they're expecting you to send work and it perhaps wasn't your initial intention to go offshore, it all needs to be agreed up front and very clear. Okay, so moving on to the next slide. What they can do, or what you would look to get from a supplier like this, is working together, as I say, from the early design stage, so that you can make sure that the design is suitable for both the prototypes and the production, because they're slightly different things. At prototype stage, you can live with design minimums and things. If it affects the yield, it's not the end of the world. At prototype stage, it might be you can relax the quality specification. You might not need a full sort of IPC class 3 kind of thing. You're really just looking for prototypes that work. But that same design, if you're looking to go to production manufacture offshore, the design needs to support that kind of production volume where yields are very much more important, and you will want the full quality specification. So the supplier will be able to give you design guidelines and advice on how to set out that design so that you know that, yes, you can get the prototypes made, but it will also be safe to go to production later on as well.
Ashley, I imagine that designing for improved yield and quality specifications are universal, whether you're planning for domestic or offshore manufacturing. Is that a good assumption?
Yeah, obviously yields are always very important, of course. No fabricator wants to make a board with a poor yield. You lose money because obviously the price is agreed up front, and in a prototype run you're only making the job once. If you find out that in that manufacturing batch that you had a poor yield, you can't go back to the customer and say, you know, we need more money, we had this kind of yield. But on the other hand, it's a one-off thing. So while yields are important for prototypes, they're not as important when you get to production. When you're doing the bigger volumes, yields are very much more important. The fabricator will be looking very closely at the design to make sure that it's not going to cause them any problems, or that they don't think it will cause them any problems. They'll want to be staying away from the design rule minimums. You know, obviously they'll have a capability that says they can do this tracking gap or that tracking gap, but for optimum yield, you want to stay away from those minimums, and the offshore supplier would be looking at the design from that point of view, and ideally looking for it to be optimized as much as possible. Any yield at that point has a huge impact on cost. And then this also ties in with whether you can take crossouts in your board, if you can take scrap circuits within the panel. again, it'll have a huge impact on price. The offshore supplier will very often give two prices, one including the scrapping panel and one without, and it will make quite a big difference. And again, that has to be agreed and clear up front so that everybody is working on the same page. You don't want to have a surprise and have a load of panels come back that have got 2 or 3 scrap circuits and you can't accept it. So again, that all needs to be agreed up front, and it will have a big bearing on the cost. So yeah, you always design to improve yields as much as possible. As I say, if you're going through one stage of prototype and then into production, you need to build all of that in at the beginning, really. Here, you look more specifically at some of the quality requirements. As I said before, you might be looking for your production boards to be IPC Class 2, Class 3, you might be working to MIL or some other standard. Now, for production, you need it to meet all of these requirements. And it might be that in the prototype stage, you're not too worried if it achieves that. As long as the board works and you can do your testing, that's fine. But the design needs to allow those quality standards to be achieved. It's very much dependent on the design. If the feature sizes and the dielectrics and things in the design are too small, then when it goes to production, they wouldn't be able to achieve the quality requirements you want. So although it might not be important at prototype stage, it certainly needs to be considered. Anything else that you need on top, fair reports or any special tests, dielectrical stand voltage, high pot testing, anything like this, again, it needs to be made clear and understood from the beginning. It might be that certain aspects of the design need to be adjusted slightly or optimized to ensure that those kind of things work okay, but certainly, again, they need to be costed in because that will have a large impact, especially on volume type production.
And things such as technical capabilities, panelization, and materials seem to have a more significant variation between domestic and offshore manufacturing. Could you walk us through those key differences?
Yeah, I think one of there's a couple that spring to mind as being quite obvious. One is controlled impedance. Now, controlled impedance will always vary between any two fabrication plants. There's always going to be very small differences in the process that individually don't make too much of a difference to your board. You wouldn't see a huge difference in dielectric or track width or anything like that, but different bonding preparation treatments, different micro etches and things can just give different profiles to the copper, and it added up, it can affect the impedance. So that's true between any two plants. So there should be some room in the design to allow a little bit of adjustment for that, just tweaking the track width, maybe the build as well, to ensure that the finished product, the controlled impedance result, is the same on the production boards and the prototype boards. You can specify the drawing very tightly and say the dielectrics must be this and the track width must be this, so you know the board will be manufactured the same way, but between two different plants that could give you a slightly different impedance result, and it's the impedance result that's important. So it'd be better to specify you need 50 ohms, and the track width, maybe the build can be adjusted to ensure that that's achieved both in prototype and production. Leading on from that, on the drawing and on the specification, it's important to have clear builds and construction so that the supplier knows what is required. But you don't want to tie it down too tightly again, because there are slight differences between the plants, and if you specify it too tightly, you just find that one or other can't quite meet that requirement, and then you're in a situation where you need concessions or things to deviate from the drawing. Panelization is, when you get to volumes, material utilization is obviously very important. It is very important even at prototype stage. Making efficient use of the panel will have a huge effect on the cost. So when you're designing the customer biscuit, the biscuit that the boards are to be supplied in, it's important to make best use of that material and avoid too much waste material between circuits. If possible, avoid sort of uneven shaped circuits that create a lot of waste in between them. But when it comes to arranging those biscuits onto the manufacturing panel, it's not so important to worry about what manufacturing panel size the offshore supplier uses compared to the domestic. They will vary, but what happens is the offshore suppliers tend to have more flexibility in their panel sizes. They can adjust one dimension or both by smaller amount perhaps, and they have a sort of a better range of panel sizes, as well as generally working with larger panel sizes anyway. So they have ways to make the best use of their panel, as long as the customer design, the customer biscuit that gets supplied to the customer, as long as that has good usage within it, then the material usage overall should be okay. Here, this is probably the biggest difference is the materials themselves, the base laminates. Obviously, we're all used to working with the mainstream sort of material suppliers over here. The customer may have a tendency to specify specific materials on their drawing, but this causes it causes more restrictions when moving offshore. Obviously, manufacturing offshore is cheaper, but the most significant savings are if you can use the offshore preferred materials. There are materials that are manufactured over in the Far East that's more readily available over there. They're on the doorstep, there's no transportation costs, and many of them are just as good as the Isolas and everything else that the people are already used to working with. Over in the Far East you have Shenyang, you have TUC, and others that they've got equivalent materials that are very good. So while the Far East suppliers can work with the materials that we use, such as Arlon, Isola, or whatever, it would be more expensive for them to do so. You can get better savings by allowing them to use their preferred materials. So on the drawing, you should really specify the IPC/ code and the category of material that you want, rather than a particular supplier or particular product. But if you wanted some control, because obviously, you know, even in the domestic market, there are good and bad materials. So a good way to getting a good compromise is to perhaps have an improved list of materials, do some testing, do some IST testing or something on a range of materials to prove to yourself that they meet your reliability requirements. And then within that list you can have some flexibility for the offshore supplier to choose the materials that are most cost effective for them, as well as obviously back in the domestic market, you know, using materials best available there.
Thank you, Ashley, for sitting down with us today. This has been a great discussion. Your contact information is being shown now on the screen. We hope that everyone enjoyed this session and that we were able to provide information that will help you with your flex circuit designs. Remember, designing and purchasing printed circuit boards should not be difficult. We hope you can join us in the near future for our next Flex Talk.